This is a short lecture on the introduction to regression analysis. It's assumed that you have little background in statistics. Suppose you are working for a consulting company. Your supervisor asks you to write a report on the relationship between sales and advertising expenditures. Your friend Julie has some thoughtful advice for you. She says, advertising expenditures are waste of money. Sales do not change with more money spent on advertising. For example, the X travel agency is very popular without spending any dollars to advertisement. On the other hand, the Y travel agency spends hundreds of dollars on advertising and does not have high sales. Julie's advice sounds quite wise indeed, but upon further reflection, you realize that firm Y starts advertising late, so the sales starting to be lower than expected. Firm X has special discounts that none of the travel agencies has at that time. But Julie has got you thinking, how do we know whether more advertising expenditures will improve your sales? More importantly, does advertising increase your sales? How can we formally test whether there is a relationship between advertising and sales? More importantly, how much can we expect our sales to increase for every additional dollar spent on advertising? Here, your experiment would be to survey a sample of firms and ask each firm how much they spend on advertising and what are their sales numbers. Record this down and then determine whether we can observe a pattern in their responses. Let's say you decide to survey 7 firms. In statistics, it's important to make sure that our sample of individuals is representative of the population. That is, we must ensure random sampling. This will allow us to make inferences or conclusions about the population at large. Each individual's response will produce a data point. That's a random sample of 7 firms will produce 7 data points for us to estimate our regression. For example, our first data point is firm A. This firm spends $2,000 on advertising and have sales of $15,000. Our second data point is firm B. This firm spends $2,000 on advertising and have sales of $30,000, and so on for the other 5 firms. In our sample, now given such data, what is the best way to present? It is a scatter graph. Let's begin with a simple X and Y graph. Advertising expenditures is on the x-axis or the horizontal axis, and 0 is on the intersection point and increases as we move towards the right. Sales is on the y-axis or the vertical axis, and 0 is on the intersection point and increases in value as we move up. The first firm in our dataset has $2,000 of advertising expenditure and $15,000 of sales. Another firm in our sample has $8,000 of expenditures and $45,000 of sales. The graph allows us to present all firms in our sample based on their combination of advertising expenditures and sales. Now, how can we determine the general pattern in the dataset? Can we observe any relationship between advertising expenditures and sales based on the points on our scatter graph? A natural way of uncovering a possible pattern or relationship is by drawing the line of best fit. The line of best fit is a line that best represents the general pattern in the sample. A regression line is simply the line of best fit for a given sample. Now recall from high school math. That's the equation of the line is equal to y equals to mx plus b, where m is a gradient or the slope of the line, that is rise over run, and b is the intercept of the line, that is where the line cuts the y-axis. In regression analysis, we represent the line as y equals to beta 0 plus beta 1x instead. All that has changed is a notation. Beta 0 is the intercept term and beta 1 is a gradient or slope of the line. In the context of this example, y is equal to sales and x is equal to advertising expenditures. Now, is there a relationship between sales and advertising expenditures? We can see this by observing beta 1, the slope of the regression line. If beta 1 is positive, then there is a positive relationship between sales and advertising expenditures. The more money spent on advertising, the higher the sales. Now, what happens if there is a negative relationship between sales and advertising expenditures? The data from our survey may look like this. We then draw the line of best fit, otherwise known as the regression line. As you can see, the regression line is now downward sloping from left to right. In this dataset, the general trend is more money spent on advertising the lower the sales are. When there is a negative relationship between sales and advertising expenditures, the slope of the regression line, beta 1, is negative. What happens if there is in fact no relationship between sales and advertising expenditures? If that's the case, our data might look like this. If we were to draw the line of best fit, the line would cut through the data as follows. Notice that the line of best fit is now a horizontal line, so when there is no relationship between sales and advertising expenditures, the slope of the regression line beta 1 is 0. Now let's take a look at how we can use a regression line to make predictions. Suppose we analyze our survey results for sales and advertising expenditures and estimate the following regression line. Again, beta 0 is the intercept term and beta 1 is a slope coefficient or gradient of the line. Many software packages such as Excel Data Analysis Toolpack, Minitab, eViews can easily estimate a regression line for us. Now suppose Excel estimates a regression line for us and informs us that the regression line is in fact y equals 10,000 plus 5x, or in this case sales is equal to 10,000 plus 5 times the advertising expenditures. This tells us that beta 0, the intercept of the line, is 10,000. This means that the line cuts the y-axis at 10,000. Beta 1 is equal to 5, which means that the slope of the line is 5. Now let's make some predictions. Suppose we meet a firm manager who's planning to spend $7,000 on advertising. In order to estimate her sales, we simply make advertising expenditures equal to 7,000 in the regression equation. Sales, or y, is then equal to 10,000 plus 5 times 7,000. This gives us sales of $45,000. Suppose there's another firm who's planning to spend $5,000 on advertising, and he would like a prediction of his sales if he were to spend on advertising today. Again, we simply let advertising expenditures equal to 5,000 in the regression equation. His expected sales will be 10,000 plus 5 times 5,000. This gives him a predicted sales of $35,000. So, what do we say about the relationship between sales and advertising expenditures? For every one additional dollar you spend on advertising is expected to increase by beta per $1 spent on advertising. So, in this case, beta 1 is equal to 5. This means for every $1 spent on advertising, sales is expected to increase by $5. How do we interpret beta 0, the intercept term? When a firm does not spend money on advertising, sales are equal to 10,000. Sales are expected to be beta $0. In our case, beta 0 is equal to 10,000, so when advertising expenditure is equal to 0, sales are expected to be $10,000. I'd like to now introduce the idea of residual term. Let's again look at our regression line for sales and advertising expenditures. As in the previous slides, that has been estimated beta 0 is equal to 10,000 and beta 1 is equal to 5. Notice that we now have the estimated regression line and the actual data points. Remember, the regression line is used to make predictions of an individual firm's sales based upon firm's level of spending on advertising. The black data points represent the actual information gathered from our survey of 7 firms. Suppose we meet Jasmine, who is the manager of firm H. She spent $7,000 on advertising. We then use our regression model to make prediction of her sales. As we saw in the previous slide, 10,000 plus 5 times 7,000 is equal to 45,000. So our prediction for firm H sales are $45,000. However, firm H in fact actually makes sales of $60,000, $15,000. The firm data point is about the regression line. The residual is the difference between the actual sales and the predicted sales. Specifically, it's the actual sales minus the predicted sales. So for firm H, the residual is $15,000. We saw that our sales prediction for firm H underestimated the firm's actual sales by $15,000. Does this mean that our regression model is wrong? The answer is no. Our regression model simply provides us with a prediction based on firm's level of spending, so it's our best guess at firm sales given the firm's spending on advertising. However, in reality, there are many other factors in addition to advertising that will affect firm sales. Because these were not accounted for, they are contained in the residual term. That is, they will cause slight errors in our prediction, so the residual term contains other factors that affect sales but are not contained in the model. In the context of sales and advertising, other factors that may influence a firm's sales such as customer service. The better the customer service the firm has, the higher the sales are. Okay, you now have a good foundation of regression analysis, and the other more advanced concepts will now make sense much more easily. Let's recap what we have covered so far. The regression line is simply the line of best fit. It's a line that best represents a general trend or relationship in the data. Beta 1 is the slope of the line. That's simply the gradient of the line, rise over run. It's interpreted as follows. A 1 unit increase in the x variable will lead to a beta 1 unit increase in the y variable. Beta 0 is a value of the y variable when x is equal to 0. In our example today, it's the expected sales when a firm has $0 spent on advertising. If beta 1 is larger than 0, then there is a general positive relationship between x and y. That is, when x increases, y tends to also increase. If beta 1 is less than 0, then there is a general negative relationship between x and y. That is, when x increases, y tends to decrease. If beta 1 is equal to 0, then there is no relationship between x and y. If x changes in value, this has no effect on the value of y. We also showed how a regression can be used to make predictions of y based on our information about x. In this lecture, we estimated the regression line. Now, if we meet a manager with a plan of spending $7,000 on advertising, we can make a prediction about this firm's sales by simply setting advertising expenditures equal to $7,000. In the regression, $10,000 plus 5 times $7,000 is equal to $45,000. Therefore, our predicted sales for this firm is $45,000. Of course, predictions aren't perfect and our prediction may be slightly off. The residual is the actual value of y minus the predicted value of y. For example, predicted sales for a firm with a plan of $7,000 on advertising. However, the actual sales may be in fact $60,000. This means using this regression, our firm has a residual equal to $15,000. Why do we have errors in our regression prediction? Because the regression model does not account for all factors that affect the y variable. In reality, there are an infinite number of potential factors that impact a firm's sales. The residual term represents all other factors other than those included in the regression model that also impact y. In the case of sales and advertising, the regression model does not include customer service or innovation. The impact of these factors will be included in the residual and will prevent our predictions from being perfectly accurate.